Hey, how are you doing? This is going to be an improved sunrise sunset demonstration using we're using the effect of optical drop, um, showing how a sunrise and sunset works on a flat Earth, and which is the real place we live in, and how if you move due south when you're north of the equator line, why Polaris will appear to drop in your view from if you were up close to the magnetic north, Polaris would appear to be somewhere above you in somewhere. I don't know if it's directly above you, but somewhere above you. And as you would move towards the equator in any direction, it would appear to drop until you get to the equator, and then um, it would appear to just disappear just as you go past the equator. But it's purely optical. It's purely down to what's known as optical drop. And this is my second demonstration of it. This has several different versions um, of the same effect. The only thing I change is filters on the versions, and I change the reflective thing I use to reflect the laser off of. So I'll just leave it play, and I'll talk you through it. Okay, move this down out of the way. Now, this is the first one. This one, each one will have a different look to it. As you can see, I'm moving it in towards the camera. I have my phone set at 0, so there's no tilt forward or back. So the center of the lens is making a parallel with the surface it's on. And I have the laser making a parallel with that same exact surface on the same exact surface. The laser is to the right of the phone. That's why it blocks a little bit of that. I can't do anything about that. It's just the best setup I have until I get a different laser. And the laser has a flat bottom that's a base to it, a flat base to it. And the whole point of it is it's a construction laser. So the whole point of that is that it can be laid on something and show a straight line across the floor or across from one partition to another or whichever. So both are making a parallel with the surface they're on. The laser is higher than the center of the lens, so it's higher than as you could see, it's higher than the center of the lens, which is about center of the lens is a bit under half an inch, and the laser is a half inch, I think, off of somewhere close on that. But there is a difference in height between the two. So that was basically the first demonstration there. I just show once or twice with this that the tilt is totally at 0, and now we'll move on to the next one. I just show it there, so just showing that the light is definitely underneath. Now the next one, I have a different filter. This I'm using, I think, as a sepia filter for this. Just show it differently with different filters. So with different filters, give it different. You get to see the effect slightly differently, but it's the same thing happening. You just get to see sometimes less and sometimes more clear. I have other filters I might use for another one. I have bigger and better demonstrations coming, hopefully, of this exact same thing, where this part won't get blocked, but it's okay because you can see it in a moment that as the box gets up close to the laser, which is right next to the phone, you can see that how much higher it is. There you go. Most of these, it's when I'm pulling the reflective, whether it be this white box or I use a white kitchen roll too, because there's a different reflection off of it. As I pull it back, often the effect is slightly better. There was other filters I could have used that would have given the laser a bigger glow all throughout. One or two of them gave it a glow that looked like it was almost exactly the same size from start to finish. but there was too much glare. I didn't realize this when I was doing it, so there's too much glare to the right hand side, so I'll have to do it again, maybe in the dark, and do that using those filters. And this third one now coming up will be in a moment, will be done in the dark. If I remember correctly, this one is in the dark. I had a filter. Yeah, this is a bit shorter, this one, because I just do it from, with this one, I just do it from on its way. Let's go back a touch. I just do it from as it's being pulled back, because there was too much layer when I was bringing it in. So this one is going to be just as it's being pulled back. So you can see it's all bright there. I can't remember the name of the filter I used. It's on the iMovie. I'll get it later. It don't matter anyway. It's just a filter. It's probably on any movie maker. So I just go back to the start of that. Yeah. Now, see it here. Just there. So there it is up here, right? Just because it's hard to see, I just want to point it out. There it is up there. So as you can see, it's a lot higher than the center of the lens. I'll leave it play away. Because my thumb makes it look like it's my thumb. So there it is again. And as I bring it back, you can see it drops down, and it looks like it's a bigger glare like the sun will give. As you can see, the glare is bigger with this one, and it looks like the sun is on water, and that kind of thing. So that's a good one. And this is the fourth one. This one I used an old movie filter, because different filters, as I said, give a different effect. So here we go. This is good because it gives a good effect along table here, as if it's along water. As you can see, and it kind of holds a lot of its angular size up to here. But I can't duplicate the sun. I might be able to try duplicate it as I get better at these, but I can't duplicate the sun because I don't know what the sun is. So how do you duplicate something you don't know what it is? All I can do is try and duplicate the glare that's around the sun, because that's what we see. Now, as I pull it back, you can see what I've done is I moved all the thing I was using forward. So my last one that I did, the last demonstration that I did, which has gotten a lot of negativity from the ball side, I was further back on the table, but this one I moved it all forward because people were complaining that the laser looked like it was pointed down and all this sort of rubbish. Not to do with that, it wasn't pointed down anywhere. But they tried to claim that, so now I'm much closer, but I have it set up so the same effect is happening. And it's this one. This is, I can't remember which one I used for this, but the name of this filter, I think it's blue, a blue filter on it. But each one gives a slightly different effect, but the same thing is happening. Always, the closer I get, the higher it rises. And I have no way to do it other than have the laser at the side of the phone. I could try doing it where I have the phone in horizontal as in portrait as opposed to landscape mode, but that is not as good. That is not as good then for viewing it on YouTube. Maybe landscape is better for that. There's a bit of focus issue because I'm filming. This is just with an iPhone 5, and I'm filming it with a camera. Filming the iPhone 5 with a camera. So Each one looks slightly different. The glare looks a little bit different with each one. So I just show again. I didn't move anything. The apparatus and everything stayed the same, but I just show every now and again that the phone is not tilted. And I think this is the last one. I'm not sure which one this is. This might be the one, the blue filter, but this shows a lot more glare and bright, which is good. You can really see it. This one is good when I'm pulling it back, bringing the box back towards the wall. It shows a good kind of a sun setting over the water effect. If I could bring it back further, I would. But at the moment, I'm keeping it that short because the bowlers are complaining that more the lasers pointed down, a load of rubbish, but they look for any reason to complain, you know, that's the way they are. They can't accept just reality, like it is what it is. And there you go, there you go, it looks like just like on the water. It's a good effect. I'm going to go back just to this part here because it's a good ending. The people don't understand. Either they don't want to understand on the opposing bowler side, either they don't want to understand, or they're making a point of not understanding, or I don't know. But they keep on doing things like that bowler, the Glober Bearded Devil. He made, even though he still showed the same effect, he made a video recently and he showed the effect, even though he tried not to show the effect. And he used a theodolite app, and all he did basically was show he was basically making his phone level, and the surface he had was pretty level, so he made pretty much a parallel with the surface, and he showed the effect. Now, as I made a video a couple of days ago detailing it, and I took screenshots from his video, and I showed how he showed the effect. Now, what he did is he made another video, and he made a point of trying to not show the effect. He still showed it, but what he did is he didn't move the object he had back as far as he had previously, trying to stop the effect from happening. Because it will look similar for a while until you move it back further and further, and then it will appear to drop or appear to rise. But there will be a point in the middle where it won't appear to rise or drop much. But he still showed it. I could take stills from his video and show that it still happened. And even though he wasn't trying to make a parallel, he still made a parallel with his first video. With his second video, yeah, maybe as well made a parallel, without, but maybe not as good a parallel as the first video. But then I don't know, because he stopped the moving back of the object, so I don't know. But I could still, as I said, there was still absolute evidence there. I could pull stills from his video and show how it was happening in his video, his second video. So it's just a lot of bowler treachery, really, a lot of dishonesty from them. They can't accept reality. They keep on wanting to use a level, making their phones or their cameras level, but they're not concentrating on the surface. Surface has to be, you have to make a parallel with the surface, otherwise you're at nothing. It's the whole point of it is you're making a parallel with the surface. So how this will work is, if I have a camera and it's 14 foot off the water level in a canal, and 6 miles away from me there is a marker, okay, that's also, let's say, 14 foot off of the water level of the canal at that exact same time, then what will happen, I look through the camera and I will see the marker looking like this. I'll be looking here, the marker will be there. It will appear that I'm looking over it. If I go to the other side and do it the opposite way back, it will appear that I'm looking over the same exact thing. It'll look exactly the same as it did. So that's happening because of optical drop due to angular size change at a distance. And maybe even some compression may be involved sometimes, but you don't need it. It's just angular size change, which is a form of compression itself, will cause that. And what I'm actually doing is the water surface is a flat surface, and I'm making a parallel off that surface. So because I make a parallel off that surface with a 14 foot high camera lens and a 14 foot high marker 6 miles away, I'm making a straight parallel, and that's what causes this. This proves that the sun is moving over a flat surface because it's showing what the sun would do on a flat surface. It's also showing Polaris, if Polaris is sorry, when Polaris is, if we go towards the north, Polaris appears to rise in the northern north of the equator. If you head due north, Polaris will appear to rise in the sky. If you head due south, Polaris will appear to drop. And this is only because of this very effect. Look, I just show you this very effect. Just give you some visuals while I'm speaking. That's all it is. This very effect. Nothing to worry about. Okay. Thanks for watching. Hope you enjoyed it, and I hope it becomes a much bigger part of the flat Earth globe Earth community debate, because there's many real world observations of stuff on the ground that show this very effect that is not in any way explainable by the globe Earth model. More to come. Thank you.